So that is easy. That is super easy. The hardest part is how do you make a CLI that people love using? Because there are many CLIs. I don't know about you, but when I use a CLI, I can instantly tell if I like it or not. It's the same as when you use a website or when you use an app. If it's not well designed, if there is something in the app that is like, yeah, like it solves the problem, but it could be better. So let's talk about what makes a CLI a joy to use. I was thinking for Swift, like, I'm going to have a look at the other CLIs. I'm going to identify the things that I like, and then I'm going to take those ideas to Tuist. And those are the things that I want to share with you today. All right, I think we can start. Hi, everyone. Thanks a lot. It's a pleasure for me to be here to start with the first talk of the day. What I'm going to be sharing today is something that I've been doing for the past 7 years. So it's kind of like very nice to be able to share all of this with you. I was thinking a lot about like how the presentation should be, and I really like when people share their experiences using the language and using the tools. So that's what I'm going to do. I don't want this to be like a university lesson. I want you to leave the talk thinking, oh my God, I want to build a CLI myself. So that is my goal today. I hope that you go next week to your company or to your project and be like, I'm going to build a CLI for this particular problem that I have. Before we start with the talk, I want to tell you a bit about myself. My name is PEDRO. I'm from Spain originally, but I live in Berlin for the past 9 years. I still don't speak too much German, but don't tell anyone. I like doing open source a lot. I really enjoy doing open source. What I like the most about it is the community. Through Tuist, I met so many wonderful people from which I learned a lot. And I love building tools for developers. I was at a company and I realized that actually more than building apps, I like building for other people, and that's how the whole thing started, and I don't see myself going back to building apps. I mean, we could say that CLIs are apps for the terminal, that's the only difference, but they are apps in the end. I'm creator of Tuist, also maintainer, and as part of developing Tuist, we also developed this library called Xcode, which allows you to read, update, and write Xcode projects. That was necessary to develop Tuist. And now I'm working full-time on Tuist and Tuist Cloud, which is a service that we're building to be able to work on this full-time. It's about sustainability in open source, which I think we're going to be talking about today in the panel. So let's talk about CLIs. Well, actually, before that, let's talk about Tuist for a second, because maybe some of you know it, some others don't. Tuist is a tool that, for the Italians in the room, I think I got this sentence right. It's Esco senza pensieri. It's like you use the tool and you don't have to think about Xcode too much. It's like it gets out of your way. So what is it? That's what the tool does. And we, in like English words, we help developers focus on building apps rather than like understanding the intricacies of working with Xcode. We make sure that everything is so optimized that they feel all the time very productive. I made a t-shirt and also a lot of stickers. I brought like a suitcase this morning with everything. So if you find me, just ask me for a t-shirt. You don't need to solve any puzzle or anything. Just tell me. I'll give you a t-shirt. So how does this whole thing of building CLIs, how did it start for me? So the first thing, I was working at SoundCloud. Like I was doing mobile development. They had a modular code base, and it was kind of a pain in the ass to do the whole thing with Xcode. And I had this itch of like, I need to do something there. It was very frustrating, like seeing developers changing stuff, breaking CI, waiting for 1 hour to see results on PRs. I was like, this is insane. Like you look at other ecosystems and they usually get feedback on PRs in minutes or seconds. Why does it have to be half an hour? Why is it breaking that often when someone changed something randomly in the project? So I was like, I want to do something. And I want it to be open source because if you do it closed source, it's just you with your ideas, with no one else. But when you make it open source, more people join and it's way more fun. So you also invite them to bring their ideas and the whole project becomes even better because you're bringing more ideas. So I was like, it has to be a CLI, you know, like something that you run in your terminal, you interact with your Xcode project. So that was clear. I didn't want to be distracted with building some kind of fancy UI. So let's build something for the terminal. And before that, I hadn't built that many CLIs. I had done some scripting in Ruby, like I guess most of you have done with tools like Fastlane or maybe some CocoaPods. So that was my experience before that. So yeah, I was thinking, okay, so what is a CLI? Because in the end, we could also say that a script is a CLI. When you run a script, there is some kind of logic in the app, in the script that you run. But I think what a CLI is taking that script that you run, and then you productize it. You think about the interface, you think about the arguments, you think about the flags, you think about the output, you think about the names. You think about the whole thing as a product. Because if you don't think about it as a product, it's just a bunch of scripts that they run, or they might not run. So that's what a CLI is all about. It's an app that you run in the terminal, and the idea is that you take a script and you make a product out of the script or a bunch of scripts. So yeah, I had an idea. I wanted to build something. So which programming language do I use for that? So I was doing a lot of Swift back at the time, so it kind of made sense to use Swift. So that's what I did. I was like, well, let's start to use Swift as a language. I used the Swift Package Manager as a tool to describe the project and like deal with everything related to building the project, running the test. I also, from Swift, it's super nice that you can leverage a type system for like checking things at compile time. I don't think I need to tell you much about like what the value of that is. You know, because you build apps with Swift. Also, it was very important that developers felt familiar, like especially because we wanted people to contribute. So if you do something in Ruby, like people are hesitant to write Ruby. And we want to eliminate all the frictions from there. So Swift felt like a natural choice for the tool. The nice thing about Swift is that you can, in the end, you can output a static binary that someone installs, and that's all they need to do. Like there are some other tools that require you to have Ruby in the system, or Python, or Node. With Swift, you just grab the static binary, put it in the system, run it, and it works. The only problem, well, this was not a problem for Tuist in particular, but back at the time, Foundation was very macOS oriented or macOS design. So it was very common to see like you use some kind of API and it doesn't work on Linux. I think this is slowly changing, but the thing is that it's taking so much time because Apple builds for their platform. Sure, like they support these others, but their focus is on this one. So until that changes, I think we are gonna be still in this world of like, will it work on Linux? Will it work on Windows? So if your goal with the CLI is to actually support these other platforms, maybe Swift is not the best tool there. And there weren't that many CLIs at the time. I think Sorcery was there. I think Christo is somewhere here. So Sorcery was there, Swift Lint, Swift Format. So those were like kind of the Swift CLIs that we could use as a reference to implement Tuist. So yeah, CLI, when you start working on it, you realize it's actually not that hard. Like any app, you have kind of like an entry point. From there, like the CLI starts. You can access all the Foundation APIs. You can send network requests. You can read some file from the system. You can run another process. Then from there, you can pass arguments. When you call the CLI and you do minus clean, minus verbose, those are arguments. You just read the values, and then you customize the logic in a way when the users pass those flags and arguments. And yeah, that's it. You have a CLI. So there's a simple example of what a CLI looks like. It's actually more involved than that, but you get the idea that you have this entry point, and then from there you start constructing the CLI. I think Nara will go through the process of what it takes to actually define the interface and everything, so don't miss his talk. So that is easy. That is super easy. The hardest part is how do you make a CLI that people love using? Because there are many CLIs. And I don't know about you, but when I use a CLI, I can instantly tell if I like it or not. It's the same as when you use a website or when you use an app. If it's not well designed, if there is something in the app that is like, yeah, like it solves the problem, but it could be better. So let's talk about what makes a CLI a joy to use. I was thinking for Swift, like I'm going to have a look at the other CLIs. I'm going to identify the things that I like, and then I'm going to take those ideas to Tuist. And those are the things that I want to share with you today. So some of the CLIs that I liked were Heroku. I don't know if you remember. I think it's still a thing. You can deploy your apps to this platform. There's a similar platform these days. It's called Fly, something similar to Heroku. The CLI is amazing, actually. They started selling themselves as a CLI first company. I don't know if you remember when the whole mobile thing started, like there was this mobile first movement. They had the CLI first thing. And the funny thing is that you can do things like buying domains from the CLI. You can do things like scaling your service from the CLI. It's mind-blowing to see how well it works. After SoundCloud, I joined Shopify. They invested a lot in developer tools. So and in particular CLI, so I could learn a lot about like what they were doing internally. In particular, they had this tool that basically every developer had installed in their environment. So it took care of provisioning the environments with the tools that developers needed to work on a particular project. You just did dev app, and it took care of everything for you. And it was amazing, because if you think about it, most of companies spend a lot of time like setting up all the environment. In that company, it was one command. You run it, boom, and then you get everything ready for you to work on the thing. And so over time, I started like noticing some patterns. I'm gonna switch to the terminal. I need to show you like those CLIs because I want you to see them, and I want you to compare that with another CLI that, in my opinion, could be much better. So let's go to the terminal for a second. And I'm gonna show you the CLI fly, which is the one that allows you to deploy services to production. So you do, the CLI is called fly CTL. Let's do help, and then we see what we get. It's super clean. You see like there are categories, different domains of the business. Then you see the commands. There is indentation that tells you this section belongs to this particular category. There are columns. So if you see like visually, it's super easy to parse the whole thing and like understand what to do there. The other one that I like is a tool called Mise, and I'm going to talk about that later. It's a tool that it's like Homebrew. It allows you to install things in your system. So let's use it. For example, they have this feature called tasks, which is similar to makefiles. You can have a bunch of tasks, and you can run them. So if we do Mise run, then you get this interactive menu telling me, oh, these are the things that you can do. Make files and don't do that. And this is super nice because sometimes I don't remember the task that I want to run. So I just run this, I select the thing that I want to run, I click enter, and then the task starts running. But not only that, I can do things like Mise task. How cool is that? I have all my tasks, like 3 columns. I can clearly see like all the tasks and what each task does. So that is an example, or those are examples of great CLIs in my opinion. But like you might wonder, like, Pedro, what is a bad CLI then? Like those look cool, but like, can you tell me something about a bad CLI? There's one that I really don't like, and I don't know if you like it, but it's a tool that you use every day. I think it starts with Xcode, I think it's Xcode build. And when you run that tool, it's like, oh my God, like in which moment did Apple decide to design the CLI that way? So let's run it for a second. I'm gonna run it against the Tuist project. I'm doing like build clean, like cleaning and then building, and then it runs, no? So let's see what we get. Hopefully we'll compile. Yeah, then suddenly you get like all these compiler like invocations, and it's like, oh yeah, what's going on here? I was like showing this to my wife yesterday, and she was like, oh, this is like in the movies. Like a terminal is like full of text that you don't know what it means, but it's full of text. That is very bad. And this is just the output. Let's have a look at the help, because it's also not ideal. So you do Xcode build. And then everything is very flat. There are no columns, there are no sections, there are no categories. You start scrolling just to see what you can do with the CLI. And it's like pure madness. It's like what you can do with it, a lot of things. Like you can create an Xe framework, you can compile, you can clean, you can list the targets, you can sign, you can... So there are no categories. So of course, like people think about building something on top of it, or like passing that through some kind of like beautifier so that the output is something more manageable. I mean, the output that you saw before is useful when you need to debug something, but not the one thing that you want to see every time. So those are examples of great CLIs, and in my opinion, a CLI that could be much better. Let's go back to the slides and let's continue. I'm going to be touching on some specifics of what makes a great CLI. So let's start from the beginning. So when you have a CLI, the first thing that you need to do as a user is to install it, no? So I was thinking, oh my God, this homebrew thing I don't like it. Like I don't know if you've run into this scenario where like 2 people do brew install in different places, and then they get 2 different versions, and then suddenly like this developer is like, oh, but I get a different output, and it's like, no, but I get this one, and then suddenly like they spend the whole day figuring out that, you know, like they're using different versions of the same tool. That is because homebrew is not good at that. Like homebrew is unable to deterministically make sure that every person using the project using the same tool. So in my mind, I was like, no, like we don't want Tuist to be like that. So we started thinking like, what can we do about that? So we came up with this idea that basically we call it Tuist Env. And this is the idea that instead of you go through Homebrew, and then Homebrew takes care of all of this, we're going to develop another CLI. So when you install Tuist, you install this other CLI that does the version management. And when we install it, we call it Tuist. We change the name. And then developers liked it. What the tool does is it's just there, you call Tuist, and if the version is not there, it pulls it for you automatically, and it runs it. If there's a newer version and you don't have the version locked, it will magically pull the latest version and run it. And if you want to lock it, you want to say, I want to use the same version in every single environment. The tool makes sure that every person is using the same version. And like, sure, like some of you might think, well, I don't really care if someone else is using a different version. Well, you don't care, but the company really cares because it's really, you're going to end up wasting a lot of time. So what we had in the end was this script where you say, like install Tuist, run that through bash, and then it takes care of doing the whole installation. And from that moment on, you just use Tuist. And then if something needs to be installed, something needs to be updated, it happens. We had that tool for so long time, and then eventually there was this tool which you just saw that does exactly what TwistM does. It's like a better version of Homebrew that is able not only to install a version and deterministically, but it's also able to log that version for every single environment. So in the last version of Tuist, we looked at this tool and we were like, they do what we do, but better. So instead of us focusing on version management, which is not really what we're doing with Tuist, let's delegate everything to the tool. And the interface is something like this. It's very cool. You say, install this version of Tuist, or install the latest version, use this version globally, use this version for this project, and then the tool takes care of everything. It was kind of a pain in the ass to ask people to migrate to this system. They can still use Homebrew, but it's so much better. The other thing that, when I was working with Xcode, I don't know if it happened to you, but it is super annoying when you start compiling something and then you go on to do something else because it's compiling, and then after like 5 minutes, it failed. And it's like, why do you wait like 4 or 5 minutes to tell me failure? Like, there are things that you could know ahead of time. So I was thinking, like, if we build a CLIs, we should make sure that they fail as early as possible. So we started like building on the assumptions that things can fail, and then when it happens, we try to be as explicit as possible about the things that happen. A lot of the CLIs that I see out there, they ask, as a developer, when you're building the app, you are focused on, like the happy path of this is my business logic, this is what I want to achieve in the end. And if I get an error or this scenario that I don't know how to handle, I can just throw the error, but that error will bubble up to the user, and then they get this weird error that they are unable to do anything with it. So I was thinking, Tuist needs to do things differently. Like, whenever you throw an error, you need to think about different things. Things like, you need to tell the user what happened. Like, hey, we were trying to do this happened. What Tuist was trying to do. Like, we were trying to load this thing, we were trying to compile your Xcode project, it failed. And what you can do about that. Imagine you're a user, you run something in the terminal, you want to know what to do next. Most of these tools don't tell you what to do next, so you get this error, and the next thing that you do is like, you keep trying, you keep like wasting your time, or maybe you end up creating an issue. So we didn't want Tuist to be like that. That's an example of an error that when you do like fatal error somewhere in the CLI to abort the execution, that you get this, okay, in line 55 of some internal command, it failed. And it's like, do you think that's relevant for the user? It's like the class or the Swift file that you're using internally? It's not really useful. So what is something better than that? This is something like, in Tuist we're iterating towards something like this. We have something in between what you saw and this thing. But the idea is whenever a developer faces one scenario that they don't know how to handle, they just throw an error. We have a structured error that requires developers and contributors to specify the description of the error. And we're going to include things like what to do next, and what was Tuist doing, and also if it's a bug or an abort. And what that means is, if it's an abort, it's something unexpected, but it's not a bug, so you just exit and that's it. And if it's a bug, you just take the error and report it, because you want to continue debugging that on your side. We basically told everyone that they should not be using fatal errors. So if something is unexpected, you just throw. And then we have an error handling logic that makes sure that whenever those errors are presented to the users, they are very consistent. As you see in the example, that you can see what happened, like some context, we were trying to find a project and we couldn't find it. And like it tells the users, hey, make sure that this workspace that you were trying to use is a valid path and it actually exists. So you know what happened, you know why, and then you know what to do next. And this is something very important, like when you are developing the CLI and then you think the user knows what you know, and then in your mind everything should be fine if you just throw all the context up to the user. That's not really the case. Not just for CLIs, but also when you build apps. The users don't really know how you are naming your Swift files or classes or anything. So always take the time to think about how the whole thing is going to be presented to the user. We tried, you probably use in your app some kind of like SDK or something for like reporting those errors automatically. We tried those back at the time, but we realized that those SDKs assume that the output that when they do prints and logs, that those are not going to be presented to the user. So when you add the SDK to the CLI, suddenly you see like logs from those SDKs. Oh, Sentry SDK loaded, whatever. And it's like, no, I don't want you to output anything to the user. They might have changed that, but back at the time, they were very focused on using the SDK on macOS apps, where you can assume that the logs are not visible to the user. But in a CLI, like pretty much every SDK did something like that. So we ended up removing that, and we just rely on users reporting on things. Maybe eventually we'll, again, consider using a platform for that. So we had like an entry point. We knew how to handle errors. We had a way of installing the tool. So we're thinking about the code itself, the architecture, like how do we structure the CLI. And the nice thing is that a lot of things that you know from app development kind of port over to CLIs. In the end, like if you use Xcode for that, you have targets, you have static libraries, frameworks, and all these different things. So anything that you apply to develop apps, most of these things really apply very well to CLIs. So back at the time, when I was at Sankula, we were like going into modularizing the app because not only for the architecture itself, it benefits, you have like clear boundaries, everything is better designed. You also have incremental builds that are more predictable. And fun fact, like Tuist was actually being developed to help modularize Xcode projects. So we follow the modular architecture. I called it like micro features. It ended up being a huge thing. Like people really like talking about micro features, so we kind of formalized the whole thing within Tuist. So we had feature kind of targets, and they represented different like areas of the CLI. Tuist generator contains all the logic for generating projects. There was Tuist automation, that is everything related to building and testing your projects. And then we had this layer of like shared functionality. We call it Tuist Graph, for example, that contains all the logic for representing your project, and core with a bunch of shared utilities. Those included also tests, obviously, and also testing target, which contain like mocks, and also testing data. And they were all compiled into a static library. And this is important. Like you probably know that with apps, it's always, you want the apps to launch as fast as possible, and for that you don't want to be using dynamic frameworks. With CLIs, it's exactly the same thing. If you launch the CLI and then the dynamic linker needs to resolve all the symbols and everything, then it takes extra time to launch. And there's nothing more annoying than running some command, waiting for 3 seconds, and then you see the output. That experience is very bad. So what I'd recommend everyone is to always compile everything statically and have a single binary that you can distribute, because that one launches instantly. That was more or less the architecture of Tuist. I did that one yesterday. So the things that you see as yellow are like dynamic frameworks. This graph is generated by Tuist. It has a Tuist graph command that gives you this output. So the yellow elements are dynamic. The red ones are static. So everything is kind of compiled together. Those dynamic frameworks are necessary because of how Tuist does all the loading of the projects. And then the things that you see blue at the top are the actual CLIs. There is Tuist CLI itself. So all that red will go into that one as a binary. The second one is a tool that, Cas, which is here from the core team, developed for like benchmarking. And he also developed another one for generating fixtures. So for us, it was very important that the performance of the tool was very fast. So we developed additional tools for, like making sure that that was the case. Things were fast all the time. So the good thing about the architecture was like that separation of concerns is always great if you do it well. You don't end up with everything depending on everything. The incremental builds were more predictable, and users could also take some of our layers and build on top of it. For example, if we had all the generation logic and you don't care about everything else, you can take that piece and you can build upon it. And that was super nice. Sometimes like developers were asking for features that we didn't have the time to implement, so you can just take one library and like use it yourself. This is something that I always recommend in the context of CLI especially, because maybe you don't want the CLI to do thousands of different things. You just want to do one, and if someone else wants to do something else, you just give them the foundational blocks. The bad thing is that if you are a contributor and then you come to the project and that's what you see, like you don't know where to start. So we could do better than, like, we want to make sure that, for example, those frameworks or those targets represent the different commands in the CLI. So if you know that you want to contribute to generate, you know that you need to start with the Tuist generator. If you want to contribute to build, you should actually focus on the Tuist build. So we want to iterate on this to improve that. That was a bit annoying for contributors. So yeah, I touched a bit on this before, but yeah, fail early because this is very annoying. We try to design things so that we can ahead of time know and validate things. And this requires a lot of thinking about like how you are designing things. Instead of like doing a design that allows a lot of implicitness, you tell the users to tell you a lot of information and then validate. So we design everything around that idea, and then the whole architecture evolved into something very functional. This thing reminds me a lot of HTTP servers. Like, how many of you have worked on like some HTTP server in Swift or any programming language? Can you raise your hands? Okay, not bad. So you know that those are like, you have this request-response cycle. So there's a request, then you do something, and then you return something. So the first thing that you always do is validate that the request comes with the parameters that you're expecting and all of that before entering that thing into the system. Then you do a bunch of functions, a bunch of stuff, and then you return. So we started looking at commands that way. It's like the user inputs something, arguments and flags, my project, then Tuist takes the two things, does the whole validation, then it constructs something in memory, and then from there you pass that through a bunch of transformations, just functions that don't do any kind of I/O operation, and eventually you write something. In this case, we write an Xcode project and workspace into the system. So because we do everything in a very functional manner, those functions in between are very easy to test. In our case, it's mostly you take a graph and then you output another graph, and that's it. So let's look at that example there. That could be like a simplification of the generate command. The first thing that we do is go to the file system and load the graph. Like, go to those files that the user has and give me something in memory so that I understand the project. Then you run that through a bunch of mappers, and it's cool because the first mapper that you see there is the one from Tuist Cloud. It could be another mapper for optimizing something. You give a graph, you get a graph, and then when you get a graph, you basically generate it. And the nice thing about that is if someone wants to focus on only the generation, they could just write the graph themselves in Swift code and use this library and then have their own generation tool if they wanted to. And then you see the second line is validation. If you validate as early as possible, also all the logic that comes after, you remove a bunch of assumptions that they don't have to make. They can safely say, okay, someone validated this whole thing for me, so we can continue. You have the CLI, we know how to, users can have a method for installing it. We make sure that the errors are like very explicit and obvious so that users can do things about them. How do we make sure that whenever we keep iterating on a CLI, things don't break, no? Like, and the first thing that comes to your mind is testing. Sure, like it's testing. We added like unit tests to every single individual piece, but then we realized, I mean, how do we make sure that if we take a project, we generate an Xcode project, that thing that we generate compiles, because that's what the user wants in the end, no? And with any CLI, it's kind of the same, no? If you want to deploy an app with your CLI, you want to make sure that if you run deploy, the thing that you get in the end is deploying. So then you start to get into this whole thing of acceptance tests. How many of you do acceptance tests in their iOS apps or like any other Apple app? I see some hands there. You know that in that case, it's kind of not ideal because you have to launch the simulator. There might be some unreliability coming from there, some slowness as well. You use some accessibility APIs. It's been a while without using that, so it's possible that things improved. But like, usually you don't really invest yourself too much into that because of the cost that it has for you. In the case of the CLIs, it's different because there is no simulator that you need to launch. There is no accessibility API that you need to use. You can just say, take the CLI and run this command. And that is very ideal in theory, but in practice, things are more complicated, and we'll see that later. So we started doing this whole thing with Cucumber, which is a Ruby, well, it's a testing framework, follows the SPDD testing stuff. The only thing is that we chose Ruby. And if you remember, like we chose Swift for like making it easier for contributors to contribute, and suddenly you put Ruby. Of course, like no one wanted to write a single test. That was kind of annoying. So eventually we said, no, let's use Xtest. And then Marek was also here, like core member of the team. So he said, no, I'm going to re-implement everything in Xtest. So we moved to Xtest, and now it's super cool because you can have breakpoints. It's much easier to understand how the execution is going. So how does it look like? How do you imagine an acceptance test being for a CLI? For an app, you have, click this button, then wait for the navigation to complete, then tap here, then scroll, then expect some element to be somewhere. This is an acceptance test for a CLI. This is an amazing work that Mark did. When I saw that for the first time, I was like, oh my God, this is amazing. Like, it reads so well. So you go and say, create a project for iOS, and with this name, install dependencies, generate the project, build it, and build one scheme in the app. It's super easy to read and understand what's going on. And you can go inside the business logic and add breakpoints and stop things if you want to. Or we also have fixtures, a lot of them. A macOS app with dynamic frameworks, an iOS app with a widget, with packages. And this is an example of one of those tests that says, take this fixture, put it in a temporary directory, do something with it. In this case, it does generate build, and that's it. Those are amazing. And they don't really take that much. I think the step that takes the longest is building, because you go through Xcode build. But if I build a CLI today, or if you think about building CLI, think about investing in this acceptance test, and make sure that you use whatever language you're using for your CLI. If it's Swift, don't use Ruby like we did. That was a huge mistake. I said that we use a lot of fixtures. We have a lot of them. Those are not all the ones that we have. I think if you scroll horizontally, you see more of them. No. So, yeah. App with plugins, app with previews, app with tasks, iOS app with extensions. The only mistake that we made there is that they are very useful. Like from time to time, we send like contributors and users to them to just look at an example. So we want to surface all these things in the docs, so that people, if they need to find for an example, they can just do it in the docs and they don't have to go into the repository. Because we run them through acceptance tests, they work. Which is something, is kind of like the common issue in code. Like you have docs referenced in the code, and then something changes in the code, and then the whole example doesn't compile anymore. You probably know that you can parallelize tests. Xcode allows that. You can have this option in the scheme that says parallelize all the execution. That is amazing. No? We have all these fast laptops. In theory, they should be able to run as many things as possible in parallel. But that's just half true. You need to make sure that your code is parallelizable. I don't know if you run your tests in parallel, but especially in the context of a CLI or any other software, you cannot parallelize something if you have some shared state that is shared across all the different commands that you're going to be running. So we made the mistake of having a lot of singletons, shared directories in the system. So whenever we try to parallelize, you increase the number of things that are happening in parallel, and you know what happens when you do that? Flakiness. So it's like you want to go faster, but you can't because there is some flakiness. So in the context of a CLI, you would do what you would do in like any other software. You would dependency inject and like control those things when you start running the test. And you would basically isolate the execution of the CLI. So instead of saying use this global cache directory, create a temporary directory just for that execution. Instead of using these environment variables that come from the system, pass them and control them from your test. And when you start isolating all these things, the CLI runs every step, every test that is running in parallel is kind of like isolated from the others. So you can increase the parallelization, and maybe when you do that, the bottleneck is actually Xcode build. But it's nice that the bottleneck is Xcode build. I think they should be able to handle multiple projects in parallel. So this is very important. When you think about designing a CLI, think about this type of isolation. Don't resort to global instances, give me the environment variables and use them, because we made that mistake, and now we have to kind of refactor a lot of things to make this happen. And if I'm not wrong, I think with the structured concurrency in Swift, this whole thing of using singletons and stuff is kind of discouraged, so you will also be kind of like nudged by Apple to also abandon this pattern. I wish they also provided an answer to dependency injection, but that's a whole different story. Fun fact of this whole work on Tuist, I didn't use it for the first 4 years. That's kind of fun that you're building something that you don't use yourself, like how do you get the ideas? So I relied a lot on users. They were coming to the project and they were like, oh, I want to use the CLI, cool, like how do you use it? And then from those ideas, I was incorporating them. And then Daniel, who is also here, he came up with this idea of like, well, why don't we use Tuist with Tuist? And I was like, yes, actually super good, like let's do it. And this is something that I recommend everyone doing. Like, don't build a CLI that you don't use yourself. Don't do what I did. Like, if you're building something, it's because you have the need. And because when you use something that you need yourself, of course, You spot issues earlier, you get a lot of ideas, you have more empathy for users because suddenly like someone is reporting something and you're like, I know, like I know myself. So that is very important. And it took us some time. Now it's super cool because we use it with Tuist, and a lot of the features, a lot of the ideas come from the fact that we're using the tool ourselves. Another thing that when you build a CLI, you might end up doing is thinking that your CLI is going to do 20 different things. Like, oh yeah, imagine you build a CLI for Apple. No? You say, I want the CLI to build my Xcode project, and I want to talk to App Store Connect. I want the tool to also manage my certificates and provisioning profiles in the system. No? And suddenly you end up with this huge CLI tool that does so many different things. So Unix actually has this philosophy that says, actually make each program do one thing well. It's like instead of like building the CLI that does too many things, like do a CLI that focuses on projects, another one that focuses on App Store Connect, another one that focuses on something else. But it's so tempting when you're building a CLI to keep adding commands. We made that mistake. So we were like, oh yeah, what if we do something about signing? And then suddenly like a signing command. What if we do this? Boom. What if we do this? Boom. And then the CLI is like, suddenly you have all these different features that you need to maintain. So really think about like, what is your CLI? What is the value proposition? What is the focus of what the CLI does? Like focus on that. And like, if you want to do something else, then think about building another CLI. A way of solving this, when people are asking you for more, and then you're unable to do that, and you don't think it's a good idea for your project, is extensibility. You say, well, I'm not going to do it myself, but you can do it yourself, extend the CLI. And then we get into this thing of like, is Swift extensible? It is not. It is really not. So extensibility in Swift sucks. It's very bad because you cannot just, if you look at other runtimes like Ruby and Python and JavaScript, you can easily load third-party code, and suddenly you have this plugin ecosystem of like developers building for your stuff. But in Swift, there isn't such thing. Or if there is, you can find me after the talk and we can talk. So all you can do is use executables. And you know who else uses executables? Apple. You know how macros work? Macros are executables. So when the compiler finds a macro, it uses a system process to call this executable, it serializes the input, it gets the output, and then it basically does the whole unfolding of the code, like using AST as kind of like a language for communication. The problem with using system processes is that suddenly you have all these problems that you wouldn't have if the language itself provided answers for these things. Like, okay, so how do I publish an executable? In Tuist, we invested in a plugin system that was based on executables. So how do I publish this? Where do I publish this? So Apple had to answer those questions as well. So they said, well, how do I publish executables? So Swift macros are packages. Easy. No. Next question is like, how do you install them? Well, we use SPM. It will like pull the code and like it will compile. How do you support it? Like, how do you compile the whole thing? Because it needs to be compiled. And they say, well, we compile it for you. And then you are like, that's not a good idea, Apple. My build time's like double or like increased by, I don't know, 5 minutes because suddenly you have to compile this with macros. So ideally, Apple would say, well, the macro is distributed as a binary, but they are not doing that. So suddenly you have all these problems. And on top of that, how do you debug the macro? So they came up with their own proprietary way of debugging the whole macro in Xcode. Very proprietary, very coupled to Xcode. So if you want to do something similar for your own extensibility API, you have to reinvent the whole thing. The only compiled programming language that I've seen doing something very well is Go. HashiCorp has this tool called Go plugin, and it's super cool. It uses system processes. So in the end, you run this other process, but the communication is done with gRPC, and the communication is a structure. So from one side, you call the code thinking that you're actually running everything within the same process, and everything is abstracted away. So what's happening actually is that you're actually calling code that is running in a different process. And it looks so transparent, it's delightful, and I really wish there was something like that for Swift, so maybe we'll do something there. And related to extensibility, I see this from time to time, like people wondering, like, why don't we have a fastlane in Swift? Like it would be cool, no? And I think always the answer to this is like, because the cool thing about fastlane is, one thing is the tool itself, but also the extensibility, because it's so extensible thanks to Ruby. Then suddenly you have this huge ecosystem of plugins that is actually one of the biggest values of fastlane. So I think we'll see something like fastlane whenever Swift answers extensibility. That's my guess. Whenever that happens, I think then we'll see a lot of interesting stuff happening. Until then you have to use system processes, which honestly, like we did it in Tuist, is such a bad idea. The other thing that we saw a lot of people doing is, when you're building the CLI, you start like, print, I'm loading the project. I'm pulling issues from GitHub. I found the issues for you. No? Imagine when you are the only person doing that, you kind of have an idea of like how the different logs are going to be presented, and maybe you use indentation to make the whole thing visually attractive or easy to parse. But then when you have a lot of contributors adding prints here and there, the whole thing becomes like a rainbow or like a Frankenstein. So this is an example. I don't think this is too bad, but I think it could be better. This is an example of the generate command when you run Tuist generate, and it generates a project. Suddenly you see a blue color there. Like, what does blue mean there? I have no idea. Then there's something related to the cache, which is nothing, like I would expect the blue to be a section, so I would expect everything under that to be indented. But really it's not a section because the second line has nothing to do with the line above. Then it runs, it pulls a bunch of binaries for optimizing the build. Then again the blue, and then some kind of it completed. But after it completed, then I see the project, the time that it took to do the whole thing. That's not great. But the thing is that it's very challenging when you have a lot of people contributing and a lot of people doing prints here and there, because how do you control that? So we started thinking about that, and what we want to do is some kind of design system. I know it sounds weird, like a design system for a CLI? Yes, a design system for a CLI. Because design systems, what they solve is like when you do software, you want things to be visually consistent. So that consistency is something that you can also, the idea, you can also bring it to CLIs. And one thing that is very important when you work on the CLI is that so you are a designer. So most likely you developer, you're also the designer. And you don't design with pixels, you design with text. So you have to think about the language, you have to think about the verbs, you have to think about the flags, how you name things. You have to think about how you structure the whole content in the output. So it's really about text, about language. And language is something that we use for communicating. So in theory, it should be transferable, the knowledge. When I was working at Shopify, we had a content designer just working with us on the CLI. So whenever we had to come up with an error message or like some kind of naming something, the whole thing was a huge discussion. Like, oh, should we name this serve or dev? Should this be deploy or launch? It's like, we had many of these discussions, but the one thing that I learned over the years is that whenever you have to think about how to name things or what conventions to use, look at the other CLIs. Because if you mimic what the others are doing, also the developers that are coming from those CLIs to your CLI, they know what to expect. They feel everything is familiar. And we humans like this type of familiarity. So what are we doing next? I touched on some things that we consider important. I also briefly mentioned some mistakes that we made and that you should be aware of if you venture into like building a CLI. So the output that you saw, we need to improve it, definitely. We need to go through every single command and like see what exactly they print and see. You saw before that you can use columns, you can use indentation, you can use underline. So maybe play with all these different things. We are going to enable parallelization. This is very important. Like in the end, you want things to compile fast. Tuist does something to compile fast, but you still want to use everything that's available. And if Xcode and your laptops allow parallelization, when it comes to you, if you build the CLI, think about this. When you design the architecture, the code patterns, like remember this, it's very important. We are going to build a design system as part of that. We are working on a design system as part of that. So if you build a CLI, it's going to be cool. Like there will be more foundational packages that you can build upon. We are going to iterate on the modularization. I said before, there are all these different targets with kind of confusing names, and people come there for the first time and they don't really know where to start. So this is something that we wanna change so that people understand exactly where to contribute. And we're going to invest in that kind of like a plugin solution. So we want to do some kind of, can we take that Go idea and like, can we bring it to Swift? Because I think if we answer that, then we answer extensibility. And if we answer extensibility, maybe we'll see more fast lanes in the Swift ecosystem. Go was able to do it, and they are also a compiled language, so I think the idea should be portable to Swift as well. Before closing, I want to show you something that I prepared for the presentation. I was like, I wanted to see, I showed them this ugly Xcode build kind of log, and I was like, I want to show them how I would personally do it better. So I built this tool called Xcodehero. So what it does is kind of like what Xcode build does, building your project, but with a much better output. So let's go to the terminal and see what the tool does. So I was showing you before everything Xcode build. You saw that like the help is not very useful. The output is kind of like messy. So let's try with Xcodehero. I'm going to do minus minus help. Of course, you will see like less stuff because it's much smaller. But you see like the columns, you see the sections, you see there's one command, it's easier to parse. Even if we added more stuff, I think it would still be easier because all the flags that are related to build, I only see them when I do build minus minus help. So if I do build minus minus help, I only get the help of the build. This is all done by this package by Apple called Swift Argument Parser. If you need to build a CLI, I would recommend to use that one. It's amazing. So there you see that we have a bunch of options that we can pass to Xcodehero. So I'm going to invoke Xcodehero so you get the sense of what it does. And I'm going to do no TTA, which means the terminal is not interactive. Interactive terminal means you can read the standard input from the user. So let's assume that this is going to be, imagine a CI environment that cannot read the standard input. And then I'm going to do verbose. So that's familiar, no? Like, so that's what you saw before. It's like the same logs that you would see in Xcode build. We don't do anything on top of that. Let's get into the interesting parts. So I'm going to post this, and then I'm going to run the same thing. But I'm going to remove the interactive, and I'm going to remove the verbose. So what you see is there's this kind of a spinner. It's telling me that it's building something. And then there's a sense of progress. I see a spinner there. So something is happening. I don't need you to add all this noise to my terminal. I don't really care. And then I want to see a bit of like what's happening, like what are you compiling? And then you see that basically the content above the thing is the actual logs that are coming from Xcode build. We run them through this tool called Xcodehero. And that's it. And when it completes, the whole thing kind of collapses. Then you get the line says like it completed, and I get this successful message in the end. Not only that, you have a lot of flexibility. For example, let's say you don't want to use colors, so you can do minus minus no color, and then you get the same thing, but without colors. So you can do the same thing and say, I don't want colors, but I want the tool to be to not be interactive, because that whole thing about the spinner doesn't work on CI. Do you know by any chance how you do interactive components in the terminal? Does anyone know? See a hand there. So they work. It's like movies. You know, like a movie is a frame after another frame, and then eventually the whole thing, yeah, it's a movie. So terminals are the same. So you print something. You say, that thing that you saw before with the spinner, you print that in the terminal. And then you can control there's a cursor, so you can control that. So when you print the whole thing, you go back, you say move the cursor to the left, to up, and print the same thing again with the spinner rotated. Go back, do it again. Go back, do it again. And when you do it too fast, you think it's a movie. It's something dynamic, but it's not. So that thing of moving the cursor back and up and again and back again, that doesn't work on CI in non-interactive environments. So when you run this whole thing on CI, you need to make sure that you have the non-interactive version of the CLI. That's why I built a non-interactive version. It's like if it's CI, like it's not interactive, so you get the same. Actually, let me clean. So you still get some kind of formatting. You see, you don't see all these like noisy logs that you would get from Xcode build. It's easier to parse. I disable the colors, and there's no dynamism there. So this is the type of control that you need from a CLI. You need the flexibility to be able to do these things. And this is what, in my opinion, are good CLIs. I'll go back to the slides. Actually, yeah. So yeah, to sum it up, building a CLI is actually not that hard. It's easy. The hardest part is to make it enjoyable to use. So pay attention to detail. It's like designing something. The terminals are very constrained. You cannot do a lot of things, but it's crazy when you have all these constraints, all the things that you can come up with. You saw that like suddenly with a spinner, a color, like indentation, like the whole thing looks more appealing. So that's, I see like limitations as actually an opportunity to build like more creative stuff. As I said, like everything is language in the end, so the only things that you can do is you can change the color, you can indent, you can add spaces, and you can underline. You can also add hyperlinks, so with those things those are your tools at your disposal. Make sure that you architect everything for maintainability, for readability. I think the whole modular architecture thing is a good idea. So if you do it with Swift and Swift Package Manager or Tuist, make sure that you do it. You don't need to do it from the beginning, but at least if you think about that thing being a long-term thing, invest in this type of modularization. Acceptance tests are fast compared to having to launch a simulator, use the accessibility API, and very reliable. And like make sure that you remove the friction for contributors. That was key for Tuist. Like when we started removing friction, we saw like people more inclined to contribute, and people contributing means the CLI gets better. And yeah, I think we'll talk about the whole thing of open source and contributors later in the panel. And just to close, one final thing: all these components are going to be open source. I created this repository called Swift Terminal. And it's still like in progress. We're going to be adding documentation and a bunch of things. And this is an example of one of the components that we develop. We're making them themable. So when you call the component, you can post a theme and say, like, this is my main color, secondary color, error, and this. And then that example that you see there, we use purple as a primary color, like pink. And that's an example of like how Tuist could use that component for telling the user that we are uploading frameworks to a cache. And then you see like the different frameworks that we are uploading, the percentage, and it's cool that when it finishes one of them, then it kind of starts collapsing the whole thing because you don't really care anymore about like 100%. And then you see like A completed, C, and then when the whole thing completes, it tells, you know, like I'm done, continue, kind of thing, you know? So yeah, those will be available. So if you venture into like building CLIs, check those out. And yeah, that was it. Thanks a lot.
That was super good, right?